Okay, so we are starting section 5.1.2, which is a little bit of an intro to section 5.2. These are properties you learned in Algebra 2 and you worked with in Algebra 2. They're not any more difficult. So there's some strategies here, and there's different ways to approach it depending, if you're working with me or a different teacher or a different tutor. I really think that this method is going to give you the most success, not only in this chapter, but also when you have to deal with concepts in future math classes. So we're looking at number 1 here, and it's 8 to the 2/3 times 8 to the 1/2, right? So you could jump right into your properties of exponents, right? Same base, you're going to add the exponents from there. But that's not always going to be the case where the bases of this are the same. So I'm going to give you a method that you can use. So what you want to do is you want to take the base 8 and rewrite it in a prime factorization. It doesn't always have to be a prime factorization, but that's the best, right? So in this case, 8 is really 2 times 2 times 2, which is 2 cubed right here. And that, in the beginning might take a little bit of time to figure out, because it's kind of a, you have to test numbers and powers. So it's a guess and check, and you can use your calculator to check. But you'll start to learn that a lot of these bases where you're going to have to reduce into the prime factorization, they're going to be the same numbers over and over again. So 8 is really 2 cubed on both of these fractions. And then, I'm raising both of these new bases, 2 cubed, to the 2/3 power. So that's going to pull in that property. When I have a power raised to an exponent, I multiply the two exponents together. 3 times 2/3 leaves us with just 2, right? So now I have 2 squared from the left term factor. And then on the right factor, I have 2 cubed to the 1/2. So then that's going to leave me with 2 to the 3/2 after I multiply the exponents together here. All right, so then, in this case, 2 squared is nice because we want to convert it to 4, which we did. But when you're simplifying and working with these exponents, it's not acceptable to leave an improper fraction. That's where the numerator is larger than the denominator. It's not acceptable to leave an improper fraction as an exponent. So we have to break it down, right? And there's different ways to do it, but the one way that I think is pretty easy is if you convert this improper fraction to a mixed number, 1 and 1/2, then what you're going to do is you're going to decompose this 2 to the 3/2 into 2 to the first power right here, times 2 to the 1/2 power right here. And that's acceptable. So you're allowed to leave fractional exponents in simplified expressions as long as they are positive, as long as they are not improper, and as long as they are not in the denominator. So in this case, I have 4 times 2 to the first, which is going to give me 8, and then 8 times 2 to the 1/2, and we leave it as is. And we're completely simplified. Now, some of you might not want to reduce these bases right away and find it easier to, deal with the straight up rule of exponent when the bases are the same. You add the exponents, so that's possible. So I'll work through that one with you. So we're going to have to add 2/3 to 1/2, which I have right here. And then we need a common denominator of, what's that, 6. So I convert to common denominators, and I end up with 4 plus 3 is 7. And so our new fraction becomes 7/6. So this expression here can be condensed into 8 to the 7/6 power. This is also an improper fraction, 7/6. So we have to convert it to a mixed number, which is going to give us 1 and 1/6. And then I'm going to decompose 8 to the 7/6 into 8 to the first, and then 8 to the 1/6 here. Problem with this process here is that 8 to the 1/6 technically isn't simplified because there are factors of 8 that will work with this exponent here. So you still have to break this into the prime factorization, right? So it's still 2 cubed. And then I'm going to use the power to an exponent property, where I'm going to multiply these exponents, 3 times 1/6, which is going to give me 1/2. So then I have 2 to the 1/2 here. Again, same answer as I had above. So you can do it this way, but it's in some cases it might feel like it's less work, and in other cases it might feel it's more work. Okay, so the next one, same idea here. It's just a division, a quotient instead of a multiplication, right? Same property. So I'm going to take the 8s as bases and rewrite them as 2 cubes. So I have 2 cubes and 2 cubes, both to the 2/3 and 1/3 exponent here. And then I'm going to apply the properties, right? So when I have an exponent raised to an exponent, I multiply. This right here is giving me 3 times 2/3, which is going to leave us with just 2. So the numerator is now 2 squared. Denominator, 2 cubes to the 1/3. I'm going to multiply those exponents, and I'm going to be left with 1, which is going to leave me as 2 to the first, or just 2. And then at this point, these bases are the same too. So you could subtract the exponents and get 2 to the first and say your answer is 2. Or you could look at it as it's 4, 2 squared divided by 2. 4 divided by 2 is 2. So lots of different ways to go about it. And then some of you might want to just use the same method as I used down here, but with the quotient, right? Same basis. You're going to subtract the exponents, 2/3 minus 1/3. Common denominators exist, so I'm just going to subtract, and I get 8 to the 1/3. But again, this can be simplified. So 8 in the prime factorization is 2 cubes. So 2 cubed to the 1/3. We're going to multiply the exponents and get 2 to the first, which is 2 again. So different variations that you can use. And that's the first 2 examples here. So these are called rational exponents. Rational means fractional exponents. And that's the direction we're headed for the rest of this section.